Bottom line up front, Indiana sits in the middle of a major weather funnel. Ever notice how Indiana can hit 80 degrees and then freeze in just 24 hours? It is not just your imagination. Unlike the Pacific Northwest or the Appalachians, Indiana possesses an almost entirely flat topography that lacks elevation. Most people think it's just luck, but it comes down to being a mid-latitude landmass. Indiana lacks any significant mountain ranges, offering no barriers to block approaching air masses. Without regional terrain to force atmospheric lifting or create rain shadows, synoptic scale systems maintain their full intensity as they cross. Air from the Gulf of Mexico travels north with zero resistance. Meteorologists track this moisture transport as low-level jets that frequently fuel severe convective events across the Hoosier State. At the same time, cold Arctic air spills down from Canada. Indiana is the exact collision point for those two massive air masses. When hot meets cold, things get unstable fast. This creates what meteorologists sometimes call a battleground state. Historical data underscores this, with frequent temperature swings exceeding 40 degrees during classic midwinter thaws or rapid spring cold fronts. Understanding these dynamics helps explain why Indiana's weather can be so unpredictable. This mid-latitude position means the jet stream is almost always overhead. The jet stream is a river of fast wind high in the sky. It pulls storm systems across the country like a conveyor belt. Because Indiana has no mountains to divert this path, we feel every shift. A subtle shift in the jet stream means a dramatic change in temperature on the ground. We are talking variations of 15 to 20 degrees in hours. This is why you might walk out in a t-shirt and need a coat by noon. It is exactly what happens when the Arctic air mass drops south. The air density changes, the pressure drops, and the wind speeds up. Think of it like an atmospheric highway, where our lack of terrain allows cold pools to rush southward uninterruptedly. There is nowhere for that displaced air to go but over our heads. The result is a climate that never really settles down for long. It is classic Midwest variability driven by pure physics. The underlying science is straightforward, even if our weather feels anything but normal. Ultimately, Indiana's wild weather is a direct consequence of its unique geographical position and flat topography.